Welcome to the sixth session of this integration series. In this session, we will derive some integrals applying the techniques learned from the previous sessions. We will explain integrals of logarithmic functions using substitutions and reverse chain rule techniques. We will also demonstrate more challenging integral questions involving functions with rational fractions and discover how it is easy to use corresponding integral formulas after breaking them into simpler fractions. We will solve 10 worked examples in this session.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to the sixth session of this integration series. Here, the first question in example 1 is to find and simplify dy by dx given that y equals ln of x plus the square root of x squared minus a squared, where x is greater than the modulus of a. Then the second question is to find the integral of 1 over the square root of x squared minus a squared dx. Then the third question is to find two antiderivatives based on the result of the second question. Now, as for the first question, since the differentiation of ln of x plus square root of x squared minus a squared equals 1 over the sum of x and the square root of x squared minus a squared times the differentiation of x plus the square root of x squared minus a squared, which equals 1 over the sum of x and the square root of x squared minus a squared times open bracket 1 plus x over the square root of x squared minus a squared close bracket, which can be further simplified to 1 over the square root of x squared minus a squared. Accordingly, as for the second question, the integral of 1 over the square root of x squared minus a squared dx equals ln of x plus the square root of x squared minus a squared, where x is greater than the modulus of a. As for part A of the third question, the integral of 1 over the square root of x squared minus 5 dx, which equals ln of x plus the square root of x squared minus 5, where x is greater than square root of 5. Here we continue to work on the part B of the third question of example 1. Based on the result of the second question, as well as part A of the third question, the integral of 1 over the square root of x squared minus 4, valued from square root 5 to 3 dx, which equals ln of x plus square root of x squared minus 4, valued from square root 5 to 3, which equals ln of square root 5 plus 1 all over 2, or in parentheses, after being simplified. Example 2 is to find an integral of 1 over the sum of x and the square root of x dx. Based on the substitution technique we have learned, we let u equals square root of x, which gives x equals u squared and dx equals 2u du. Hence, the antiderivative can be written to the integral of 2u over the sum of u squared and u du, which equals 2 times the integral of 1 over the sum of u plus 1 du, which equals 2 times ln of u plus 1, or in parentheses plus c. After back substituting to the variable x, the antiderivative equals 2 times ln of square root of x plus 1, or in parentheses plus c. Here example 3 is to determine the integral of x squared over square root of x cubed plus 1 dx. Since the differentiation of x cubed plus 1, or in parentheses, equals 3x squared, hence x squared dx equals 1/3 times d x cubed plus 1, or in parentheses. Hence, the antiderivative equals the integral of the reciprocal of square root of x cubed plus 1 times 1/3 times d x cubed plus 1, or in parentheses, which is written to 1/3 times the integral of x cubed plus 1 to the negative 1/2 dx cubed plus 1, or in parentheses, which equals 2/3 of the square root of x cubed plus 1 plus c, after being further simplified. Example 4 is to determine 3 logarithmic function related antiderivatives. As for the first one, since the antiderivative can be written to the integral of 1 over x on ln of x dx, it is written to the integral of 1 over ln of x d ln of x by dx, which equals ln of the modulus of ln of x plus c. As for the second antiderivative, it can be written to the integral of ln of x times 1 over x dx, which equals the integral of ln of x d ln of x by dx, which equals 1/2 of the square of ln of x plus c. As for the last antiderivative, according to the product rule of differentiation, the differentiation of uv, or in parentheses, equals the differentiation of u multiplies v plus u multiplies the differentiation of v. Hence, the integral of u dv equals u times v minus the integral of v du. Now, we let u equals ln of x, dv equals dx. Hence, du is 1 over x dx, v equals x. Then, the antiderivative can be written to x ln of x minus the integral of x times its reciprocal dx, which equals x times ln of x minus x plus c. Example 5 is to find an integral of 2x over x minus 1, or in parentheses squared dx. We start to let u equals x minus 1, then x equals u plus 1, dx equals du. Hence, the antiderivative can be written to the integral of 2 times u plus 1 over u squared du, which can be written to the integral of 2 over u du plus the integral of 2 over u squared du, which equals 2 times ln of the modulus of u minus 2 over u plus c. After back substituting to the variable x, the antiderivative equals 2 ln of modulus of x minus 1 minus 2 over the result of x minus 1 plus c. Example 6 here is to find the integral of 1 over the sum of 1 and square root of 2x dx. In this question, we let u equals square root of 2x, so du equals the reciprocal of square root of 2x dx. So dx can be written to u du. Hence, the antiderivative is written to the integral of u over the sum of 1 plus u du, which can be simplified to the integral of du minus the integral of 1 over the sum of 1 plus u du, which equals u minus ln of modulus of 1 plus u plus c. After back substituting to the variable x, the antiderivative equals the square root of 2x minus ln of 1 plus square root of 2x, or in parentheses plus c. Here, example 7 is to find an integral of 1 over the sum of 1 plus square root of 3x dx. Similar to the previous example, we start to let u equals the square root of 3x, then du equals square root of 3 over 2 square root of x dx, which is written to 3 over 2 times 1 over square root of 3x dx. So dx equals 2 over 3 of u du. Hence, the antiderivative equals 2 over 3 times the integral of u over the sum of 1 plus u du, which can be written to 2 over 3 times open bracket the integral of du minus the integral of 1 on the sum of 1 plus u du, close bracket, which equals 2 over 3 of u minus 2 over 3 of ln of 1 plus u, or in parentheses plus c. After back substituting to the variable x, the antiderivative equals 2 over 3 times the square root of 3x minus 2 over 3 of ln of 1 plus square root of 3x, or in parentheses plus c. Example 8 is to find the integral of square root of x over the result of square root of x minus 3 dx. We start to let u equals square root of x, then x equals u squared, which gives dx equals 2u du. Hence, the antiderivative can be written to the integral of u over the result of u minus 3 2u du. After being further transformed and simplified, the antiderivative is written to the integral of 2u plus 6 plus 18 over the result of u minus 3, or in parentheses du, which equals u squared plus 6u plus 18 ln of the modulus of u minus 3 plus c. After being substituted back to the variable x, the antiderivative equals x plus 6 square root of x plus 18 times ln of the modulus of square root of x minus 3 plus c. Example 9 is to determine the integral of the cubic root of x over the result of cubic root of x minus 1 dx. First, we let u equals cubic root of x, then x equals u cubed. Accordingly, dx can be expressed to 3u squared du. Hence, the antiderivative can be written to the integral of u over the result of u minus 1 times 2u squared du, which can be written to 3 times the integral of u cubed minus 1 plus 1, or over the result of u minus 1, or in parentheses du. Now, it can be seen that the numerator of the integrand can be factorized, and then the integrand can be further simplified. So, the antiderivative is written to 3 times the integral of u squared plus u plus 1 plus 1 over the result of u minus 1, or in parentheses du, which equals u cubed plus 3 over 2 times u plus 1, or in parentheses squared, plus 3u plus 3 ln of the modulus of u minus 1 plus c. After being substituted back to the variable x, the antiderivative equals x plus 3 over 2 times cubic root of x plus 1, or in parentheses squared, plus 3 cubic root of x plus 3 ln of the modulus of cubic root of x minus 1 plus c. Here, example 10 is to determine two antiderivatives. As for the first one, since the differentiation of the fractional function 1 plus sine x all over the sum of 1 plus cos x equals cos x times 1 plus cos x or in parentheses plus sine x times 1 plus sine x, or in parentheses all over 1 plus cos x, or in parentheses squared, which is simplified to the sum of cos x plus sine x plus 1 all over 1 plus cos x, or in parentheses squared. Hence, the n-type derivative is written to the integral of 1 plus sine x all over the sum of 1 plus cos x, d 1 plus sine x, which equals 1 over 2 times 1 plus sine x all over the sum of 1 plus cos x, or in parentheses squared plus c. As for the second antiderivative, since the integrand can be written to x to the 7th over x to the 8th times x to the 8th plus 1, or in parentheses, which can be further simplified to 1 over x to the 8th minus 1 over x to the 8th plus 1, or in parentheses times x to the 7th. Hence, the antiderivative can be written to the integral of 1 over x to the 8th minus 1 over x to the 8th plus 1, or in parentheses times x to the 7th dx, which is written to 1 over 8 times the integral of 1 over x to the 8th minus 1 over the sum of x to the 8th plus 1, or in parentheses dx to the 8th, which equals 1 over 8 times ln of the ratio of x to the 8th to the sum of x to the 8th plus 1 plus z. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.